Hello, testing. Hello, hello, hello. All right. Good morning, everyone. So, welcome to Study with Me. So, hi, everyone. Welcome to this Study with Me class. So, this is a live stream. Please, if we're going to chat, please let's be polite and also like and follow this channel if you like what we are doing. So the channel is all about software engineering, agentic AI, and you know, uh, machine learning and deep learning and mathematics that combine them. So industrial application, coding, basically coding, agentic AI, and everything. And then we are going to be doing a lot of study. This is a live session where you will see most of the thing I do on day to day. My activity is study, write, teach, and consult. So I am a data engineer and an agentic AI consultant. And I read a lot. I am a solution architect as well. So we'll be studying a lot of book and then I'll be streaming the section. Please, if you'd like to join, so the time is will be basically around this time as well, or you can watch the video later. So the book we want to study today, we're going to be studying this book by Vlad Khononov, which is Learning Domain-Driven Design, Aligning Software Architecture and Business Strategy. So this book was published by O'Reilly. It's a very good book. I've not read it. So we are going to read it together, actually. So it was published in 2022. Um, you know, its application is going to be popular now because of agentic AI. So what I do is I summarize this book to save our time. I normally summarize this book into readable, readable pages. Like we have 26 pages now, summarized into 26 pages. So we'll be studying the 26 pages together. We have the summary. Please get your jotter so that you can take handwritten notes together. So the pattern is we'll study, then we'll do the summary, then I'll just explain what I have learned in the book to you in one word. Then I will take notes for my book that I'm currently writing. The book I'm writing now is a CADABA. The short form is CADABA. The full meaning is Cognitive Architecture Design for Autonomous Business Agents. So it's a fantastic book. I've also written one book, which is multi-agent orchestration or patterns for enterprise scale system, where I discuss various orchestration patterns and how you can build harness engineering, how you can build around agents to make it governable and secure in an enterprise setting. It's available on Amazon, and of course, I can also show you the book here. Let me see if I have the summary of the book, so you can see it for yourself. The book is here. And then I have the cover image. So let me just show you the cover image. Covers. So you can see this is the cover image of the book. It's a very fantastic book and you learn a lot. So it's available on Amazon, Multi-Agent Orchestration Pattern for Enterprise Scale System. All right, so let's go to our study, follow the pattern squarely. I know it will take us like maybe 2 hours to finish, but we can do it, we can do it, we can do it, guys. We can do it. Let's do this. Oh, just a minute. Let me see if I can share and copy the screen to send to someone. send it to myself. This is just a form of advertisement, guys. So sorry about that. So let's go to our study now. Hello, hello. So please, if you can't hear me, just kindly say, okay, so that we can just adjust where we are. So this is the book. I'm going to put it in reading mode so you can. Yep. So learning domain driven design, complete CADABA study notes, book detail by Vlad Khononov and forwarded by Julie and published in 2022 by Orally Media. So let's go through what the book is about. The book present domain-driven design as a way of aligning software architecture with business strategy. So it's just about how to package software for specific business. You know, the way you would design for a bank organization is not the way you would design for an oil and gas. And it is not the way you would design for maybe SMB or retail traders, like a restaurant, like a delivery or e-commerce. So that is what the book is all about, domain-driven design, how to design software engineering based on particular domain or based on business domain. So DDD is not merely about aggregate repositories or microservices. Its foundation is understanding the business problem. So, oh God, I've just finished a book called Intelligent Business Process and Business Process Management. It's very, very fantastic. You can get any of these books. It will also help you to understand most of these domains and how they function. So you design with the understanding of business problem, developing a shared language with domain experts, selecting appropriate models, and matching technical complexity to business complexity. So how to match business problem, uh, how to define a solution with respect to business problem. So for CADABA, cognitive architecture designed for autonomous business agent, this means agent memory, tools, and workflows should be designed around real business capabilities and rules rather than generic AI function. So this is what we have here. So we'll be studying together. During studying, I'll just be I'll not like to disturb. So we'll just study silently. And then after the summary of each chapter, then we'll come together and write and take notes and then explain. I will explain what I have learned to you, and then you can also reminisce on what we have learned as well. Okay, part one, strategic design. So we have analyzing business domains. So study start now. All right, everyone. So uh, chapter one's topic is analyze business domains. So, everything this chapter is explaining to us is that before you design any solution for any business, you should analyze all the domains. That is, the domains can be the business departments. For example, you have the procurement department, you have the finance department, you have the supply chain department, you have the operations department, you have the IT department, you have the HR department, and then you have the security department as well. So or analyze all the subdomains you have in the business before you design solutions for the business. So when you analyze all the subdomains, know all the problems of the subdomains, and then you start designing solution for the specific problem in the subdomains, and then you can bring the problem together, bring the solution together, and then you can now build a system for them. So, of course, the most important thing that I learned here, which I highlighted here, is that domain experts are the source of business knowledge. So, before you design any solution, you must get problem statement from domain expert. You must get the business understanding from the domain expert. So, and these experts can be business leaders like CEO, CTO, COO, and the general managers. They can also be operational employees, like you have operation teams. Okay, they can be head of specific department. They can be manager, like procurement manager, for instance, supply chain manager, finance manager, IT manager, and so on and so forth. And then they can also be leads in specific department. Then, as an analyst and software engineer, your own is to collect their problems, and then collect their problem, and then learn the domain from them, collect knowledge of the domain from them, and then you can now put it together to build a system. For example, as a data analyst, you cannot analyze data if you don't know the KPI. And then how do you get the KPI? You get the KPI from the business owners. Then as a data engineer as well, that's what we call requirement gathering. So, before you build any data platform, before you build any reporting engine, before you build any data modeling, you have to get the requirements from the business owners, which are domain experts. Okay, so they know the source of the data, they know what the data is like, they know how the data is generated, and they know the KPI they want to measure. So you get the source, you get the information of how the data is generated, the workflow of everything. You get the KPI, how the data should be modeled, what do they want to see on the dashboard, what particular metric are of value to the business. So when you get all these things, you put everything together, identify the source, all your data sources, plan your transformation, plan your injection and transformation, and then you model the data into star schema, and then you work with this model to build a reporting engine. And then after building a reporting engine, working with the metric and the KPI, you can now build what we call data marts, which are just reporting table that can be connected to business intelligence tools like a Tableau or Power BI directly, and then you can now start visualizing. So when you do this, your analysis will make sense. Your dashboard will make sense to the business owners. But if you don't get the knowledge from them, and then you just build based on your own principles, you may not build to their satisfaction, and then you may not be using the metric that will bring value into the business or something like that. So I also designed this is software engineering, domain-driven design. So what I'm actually reading for is a book I told you about, which is Cognitive Architecture Design for Autonomous Business System. So how can we apply uh, understanding business domain in CADABA? When you want to build a cognitive architecture for a business agent, for instance, you must understand the domain, okay? Because you can't design the same agent for every domain. Procurement, excuse me, procurement, supply chain, finance, IT, human resources, they cannot use the same agent. Yeah, they cannot use the same agent. Why? Because their operations are different. Their activities are different. Finance department works with money. They work with what amount of money is coming into the system and what amount of money is going out of the system. Like procurement, they work with a contract and customers and vendor onboarding and the expenses. Supply chain, they work with demand and supply, economic analysis and so on. And then IT department, they work with operation, monitoring, observability, providing IT support. Human resources work with, employee recruitment and employee management and all that. So you cannot design the same agent for all this. No, they need different agents, and then you must understand their business in order to design a cognitive architecture for them. So you must faction their, agents based on their own activities. And that's why we have different agents for different domains. So for CADABA application, so subdomain knowledge is very, very important. And those subdomain knowledge can be what we call the adaptive planning, autonomous workflow recovery, cognitive memory management, because you cannot use the same RAG system for finance and IT operation. Because why? Because the data generated by those systems is different. So you can't use the same data. So you must put this into consideration. The planning system for finance is different from the planning system for IT operation. Autonomous workflow recovery, their recovery system is different. So the kind of recovery system you can design for IT, maybe IT management department, for example, is different from the recovery system for finance. Because if you misprogram anything in finance and the company loses money, you'll be in trouble. You'll be designing for loss. So you can't design the same recovery process. So you must also put that into consideration. The cognitive memory management, which I've talked about, different memory, neurosymbolic reasoning. So their reasoning engine will be different, meaning that the prompts you will be given to this system will also be different. The example prompt, few short learning that you'll be designing is different because they have different, or somebody that read accountants, it's not the same, cannot operate at the level of somebody that read software engineering in software development, because their domain is different, their expertise is different from the expertise of an accountant is different from that of a software engineer. So neurosymbolic reasoning, their reasoning is different. So what this person may be seen as, right, this person can be seen it as wrong. What works for this person may not be working in this person's department. So the next one is safe business decision making. So it's also very, very important that you put this into consideration. So this capability should remain under CADABA's direct architectural control. So this is what we have learned in chapter 1. And the summary note there is that business domain describe the value of an organization, the value an organization provides. Okay, so each domain will work together to bring value to the business. Then core subdomain creates advantage and require the strongest investment. Generic subdomain are solved problem and should normally be adopted. So there are some solved problem like, for example, in many companies, they now use document intelligence. They have databases. They have all their different databases. So these are solved problems that you can build on. Then supporting subdomain are necessary, but have simple business logic. So you cannot overlook them because they are supporting subdomain. Okay, like normal IT and HR department, they support organization, by providing IT, and the other one provide employees and onboarding and management. So they are supporting, they are seen in business process management as supporting department, but they also should not be overlooked, because because they are part of the business. Without them, the business cannot function. Okay. Domain experts are the original source of business knowledge. Very, very important. That is the most important point I got from this chapter. So to get, you can't know everything, and then you can't study everything to know everything. Because we are human beings, and we can forget most of these things. So you can't say, okay, because you are a software engineer, you want to build a system for a finance company, you now start learning or reading all the finance book in this world. No, there's no time for that. There's no time for that. You will not have time to do that. So specialize in your domain. And then if you need any understanding of the system to solve a particular problem in any domain, just walk to the experts. Okay. When you are building, that's why software engineering now uses agile principle. You deliver as you build, you deliver progressively, so that if the business doesn't like it, they can easily call back or make a change. And then the software development will also accommodate the change. So always work along as a software engineer, data analyst, work with domain experts to know the data you are working with, to know the system, to know how it works, to collect metric and KPI before you begin data engineering workflow, or before you begin analyzing data. It is very, very important. All right, guys. So let's study chapter 2. All right, so in chapter 2 discusses discovering domain knowledge. So basically, we've been working with domain knowledge, and of course, most of us that are data engineers, software engineers, and data analysts. Chapter 2 discusses discovering. So most of us that are data engineer and data analysts, we normally gather what we call requirement gathering from business owners, right? So that is knowledge discovery. So requirement gathering is actually or knowledge discovery. And this chapter actually, emphasizes more on that, okay, how you gather knowledge and make sure the knowledge does not lose its value as it goes down into the code level, because you domain expert has the knowledge, right? And of course, we must say this for a fact: some domain expert does not have even full knowledge of what they are operating. Some of them does not even understand what they are doing most of the time. I've seen such a case. Pardon me, sorry. But it's a fact, right? It's a fact. Let me just use this word that they may not know how to explain those words naturally if you don't ask them. And that is why in requirement gathering, we normally use what we call the Q&A, question and answering. So instead of just allowing them to talk directly, naturally, which may not cover the problem area, which may not give you this full solution, which I've witnessed for a couple of times with my customers. So you can use Q&A. So use Q&A. For example, in data engineering, you ask what is the data source, how is the data generated, what is the current, what do you currently use to generate the data or to manage the data? Is it Excel? Is it CSV? Do you have a repository where you store the data, and so on and so forth? And then you begin to question them. You begin to question them. What are the specific columns that are of value to you in the data? What do you want to see in the visualization? What value, what KPIs do you normally measure? And who do you report to when you generate your report? Who do you give your reports to? You see your head of department, you see the CEO, you see the CTO, and so on and so forth. So those are requirement gathering. So to get the best of knowledge from domain experts, we can use Q&A to drive, their explanation. So this will enable you to also get, correct explanation for your development or for your design and for your, solution, for your proposed solution. So it from what I learned from the book, so it says that knowledge is often tacit, which we have explained. Domain expert may not have explicit considered exceptional cases. They may not have knowledge of the exceptional cases. They may not have knowledge of complex situations that they even want to solve. So questions and modeling can therefore help both engineers and experts to discover new business knowledge. So it's very, very important. Or design your requirement gathering, gather some questions that you want to ask them to expose these areas so you can understand the business better. So of course, from the summary, we have the first one: software development depends on learning the business problem. So your first thing is to learn the business problem. And how do you do that? You design a questionnaire for the domain expert, or you go directly to them and let them explain the problem or their problem to you using question and answering. The repeated translation of requirement cause knowledge loss. When knowledge move from domain experts to software developers or to software engineers, then to code, and then to reports, it loses its value. So for example, if you don't write down the correct information from the domain expert, and then you transform what you wrote into code, and then from code to reports, the knowledge will depreciate, it will lose value, and it may not even align with what you are trying to solve. So you must make sure that you take record. You can record them as they are speaking. Thank God we have AI now. You can use AI to record them, and then get summary of this information by using AI summarization, and then you can design the architecture from what you have gathered, and then you can show them the architecture that this is what you have, and then you can build a model, and then you build your code, and then you deploy, and then you show them a pilot or a POC of what you have designed. So repeated translation of requirement cause knowledge loss. Every stakeholder should use one shared business knowledge. So every stakeholder should use one shared business owner. So stakeholders, are individuals that are combined together in a project in order to drive the project or to solve the or to design a solution for a project. So for example, the business expert, the domain expert is a stakeholder. Okay, your project manager is a stakeholder, project sponsor is a stakeholder, the software engineer that is designing or developing is also a stakeholder. Your developers that are working under you as a software engineer, they are stakeholders. Even the data analyst is a stakeholder. So everybody in the project are stakeholders. There is no junior. Okay, everyone is a stakeholder. So all stakeholders should work together and use shared knowledge, not that a domain expert have different knowledge, the software engineer have different knowledge, the developers have different knowledge. We'll be building different solutions. We'll be designing a solution that will not solve the business problem. So a useful model contains only details needed for its purpose. So make sure you keep the details that is needed for the project, the details that is needed for the business domain. Do not mix it up with another detail. The ubiquitous language must evolve as new knowledge emerges. So, of course, when you, let's come into agile project management now. So for example, when you design a software and the business domain, the business expert or the domain expert decided that, okay, we are no longer, this method is outdated. We want to change our approach. We have a new problem that we want to solve. So the one that we have designed for, it doesn't actually work again. And then you can't be rigid and say that, oh, you cannot change the system. You have to accommodate the change, and then you accommodate the new problem and the solution to the problem, and then redesign your system, refashion your code, modify the code to suit what they have, and then you deploy again. Because as a software engineer, you cannot build a rigid code that cannot be changed. So make sure it's flexible and agile. So let your development accommodate changes. Okay, because as a data engineer, you have collected metrics, you have modeled the data, you have built the data mart, and then the business owner now comes and say, oh, look, Fuke, this metric I gave to you earlier is no longer valid. So we have a new metric that we would like to measure, and then we have a new model that we would like to develop. I will not say, okay, because I've built this model, this thing cannot be changed. No, I have to go back again, start the transformation, model to what they want, and generate the data map based on the new KPI and metric that is given. So this is how software engineering flows. It is agile, and then you build and accommodate changes. So applying this to what we are actually studying for, which is CADABA, cognitive architecture design for autonomous business agents, or what I particularly learned here is these two lines here, so which are very, very important. So CADABA require a governed ubiquitous language for agent goals, tasks, cases, plans, policies, evidence, approvals, exceptions, compensation, and outcomes. Okay, so you must use a governed ubiquitous language, use a governed business language. Okay, for your agent goals, task cases, plan policies, evidence and approval, and so on and so forth. So this concept must mean the same thing in agent prompts. So you must bring this business language to your agent prompts, to message schema, to memory record, to your RAG database, to policies, to user interface, and to your source codes. So the business code must be everywhere in your agentic system design. It must be in your prompt, it must be your message design, it must be your short-term and long-term memory. Of course, the message is already in your database, which you are using as the RAG database. Okay, this message, this same business language must be in your policy. Your policy must implement based on this business language. Your user interface must be designed based on this business language, and your code must be designed, or you must develop your code based on the business language, so that all the planes of CADABA will work together to solve the same problem, not solving different problems. They have the same memory, they have the same understanding, they are working towards achieving the same goal. And at the end, you will have designed a working system, that will solve a business problem. So an LLM must not be allowed to create uncontrolled terminology that gradually change the system business meaning. So even though CADABA is built on a foundation model, so, and foundation model can change, they can come with their own understanding. You must not allow the understanding of the language model to change your cognitive architecture, to change the cognitive architecture of your agent, sorry, not your own cognitive architecture. So you must not allow the LLM to change the cognitive architecture of your agents. Okay, that is why policy is there. Policy guide the LLM on what it can inject into the system and what it cannot. Okay, and that is why we said CADABA, plane must all be governed. They must all implement complete policies. They must work with business domain knowledge, and so on and so forth. So CADABA should maintain fashion domain glossaries and ontologies with domain experts validating important changes. So that is why we have a RAG database. We have business domain glossaries, which are terminologies used in the business. We have ontologies, which is just like a design database, business information that never change, that is kept forever, that must be implemented, that the agent must generate knowledge from. And then domain experts, which are also the experts in this business, must be there as human in the loop, validating every process and handling every task that is beyond the capability of the agent. So this is what we have learned in chapter 2. You can see that this book is very, very important. It's a must read for all data engineers, because you, as a data engineer, particularly if you are not working with a particular business, if you are working, let's say, if you are working as a consultant data engineer, you'll be working with different businesses. Like you'll be working with oil and gas, you'll be working with, and in oil and gas, you'll be working with different departments, working with procurement, working with finance, work with HR, work with IT, and then the data generated by this platform are different from each other. So you need domain driven design to understand each data and design a model according to the business knowledge, according to the business language, and then build a maps that can feed their reports and give them what they want to see on the dashboard, or what we generate business or drive business value. So it's very, very important. All right, guys, let's start this chapter 3. So for chapter 3 talks about managing domain complexities. So as we have said, in enterprise, you have many domains, you have many departments. So how do you manage the complexity of this domain or of this department as a software expert or as a software engineer or a data engineer? So I'm always using data engineer as an example because I've worked in an organization. Of course, I work with Seplat. I was a data engineer consultant at Seplat for about 2 years. Okay. And I work with different departments. I work with finance, procurement, supply chain. I work with HR. I work with operations. I work with IT. I work with security team. I work with production departments. So, I work with various data, various data. So that's why I'll be using data engineering as an example because this apply to data engineering even more to me than software engineering. Okay. And of course, this agentic system engineering builds on data engineering directly. They are very close. They are very close. That's why I like agentic engineering. It's very close to data engineering. So chapter 3 talks about managing domain complexities. And the 5 summary we have are a model is valid only within an explicit context. The same word may have different meanings across bounded contexts, and subdomains are discovered, but bounded contests are designed. Okay, so one team should own each bounded context. Smaller contests improve focus, but increase integration overhead. So this is very important, guys. This is very important. So when you are working with businesses, so managing domain complexity is very important because you gather requirement from HR, finance, um, IT, legal teams, operations, security, everything, and then you mesh this requirement together. You'll be building a system that cannot function if you make this requirement together. So you should implement what is known as bounded context. That is, separate the context of each domain from each other. Do not combine them. Do not combine them. So as a data engineer, you collect requirements from legal department and you are getting data from them. So make sure you model the data, transform the data, build the metric, and using the metric and KPI, build a data model and a data mat that is designed specifically for them. Do not build a dimensional model of a legal department, connecting it with finance department, connecting with IT department, connecting with HR department. No, it doesn't work that way. So you should implement bounded context when you are building. Do not mix the data of a legal team with the data of HR team, even if there is some element of interconnectedness between them. Do not connect them, even though they are connected. Even though they are connected, let them be built separately. So that's why in this system, in this book, you will see sometimes that one team should own each bounded context. That is, one team should own each domain. So if Funke is building a model for a legal team, or if I am building a model and a data mart and a data, a Power BI model for a legal team, I should not be at the same time building for finance team because there may be bounded context. There may be mixed of information. So I may cross the boundary of legal data into I may cross from the boundary. I may move outside the boundary of legal data into finance data if I'm combining them together and working and designing them together. And even if I'm designing, for example, in Fabric, you will not use the same workspace we are using for finance or legal operation. So there should be separation of concern. All context, all business domain operation must be bounded. So you must not mix them together and different teams should be assigned. So if one team is working on finance, the same team must not be working on legal. The same team must not be working on IT. The same team must not be working on HR. The same team must not be working, with other departments. So they should be specialized so that they can be focused. And, the context and the requirement they have gathered will become their second nature, and everything they are designing will be focused on that requirement so that they can generate the output that is meant to solve that particular business problem. So this is what is meant by bounded context. Operate within the domain knowledge that you have gotten. Do not mix a particular domain knowledge with another domain knowledge. Do not operate outside the boundary of a particular domain that you are currently working on. So small context improve focus, but increase integration overhead. So we can say that, okay, why do we need to separate the domain? Is it not one business? Okay, I'm working with First Bank, for instance. First Bank is First Bank. Yes, isn't all the same First Bank? So I can mix up trade data with finance data. I can mix finance data with HR data. I can mix foreign data with local data, and so on and so forth. No, so it will be hard to work with if you mix them together, and if you separate them into microservices. For example, using distributed system, you may say, okay, it will be too much, too many to manage, but it is better to manage them in pieces than to combine them together into one monolithic confusion or problem that you will not understand, that you will not be able to build well, that the business will also not understand how to use, because each domain have their own domain knowledge and they cannot operate in another person's domain. So this is why bounded context is very, very important. Every domain is bounded, so also their solution is bounded to them. Okay, so applying this to agentic system design. So you can see this line, CADABA should not use one universal enterprise agent model. Okay, CADABA should not use the same collection of agents for procurement in compliance. The same collection of agents for compliance cannot be used in finance. The same collection of agents used in finance cannot be used in legal or department. The same collection of agents used in legal department cannot be used in IT operations. So you should make sure you design bounded agents for each domain. Every agent meant for procurement is bounded to procurement. Every agent meant for finance is bounded to finance. Every agent meant for IT operation is bounded to IT operations and cannot be used for HR. It cannot be used for finance, cannot be used for security, and so on and so forth. So you can see the importance of bounded context. It helps you operate within the business context so that you will not mix a particular business domain context with another domain context, which will, be expanding the solution beyond what the business actually require. And, it can even be generating more costs. So who knows? Okay, so a context can initially remain a module in a modular CADABA runtime. It should become a separately deployed agent service only when independent scaling, ownership, security, deployment, justify the additional complexity. So the way I built CADABA is a framework that I have designed for solving enterprise agentic problem. So it's a framework where you can bring all kind of agents and deploy and integrate with company policies. It eliminates the problem of having numerous agents with numerous orchestration. Okay, so CADABA bring all the orchestration, all the harnessing, looping, everything together. Then you just develop your agent as a module, and then you deploy it on CADABA framework. That's how CADABA works. So instead of having many orchestration tools in an enterprise, you can just have one orchestration, one CADABA framework where you can develop your agent and then deploy it on it. So it can handle many agents, can handle every form of agent. It handle them as a module. So what we are saying is that if you want to deploy an agent, if you want to deploy a particular department agent, for example, procurement or CADABA framework, you deploy it as a module. Okay, it will be a modular architecture on CADABA itself. Then the only time you should deploy a framework for an agent is if the agent is very, very large. If you have the, if they have become swarms of agents, for instance, and then the business have the capacity to take ownership, to scale it independently, to secure it, to and to maintain it independently of other agents. That is why you can now deploy a framework for that agent and deploy separately from other business agents. So that is how bounded context apply to or agentic system design. So every agent is limited to where they have been designed and cannot be used in another business domain. All right. So let's go to chapter 4. All right, everyone. So let's look at what we have in chapter 4. So integrating bounded context. In chapter 3, we look at managing domain complexities. So by implementing bounded context. So how do you integrate bounded context? You look at the summary we have here. Bounded context collaborate through explicit contracts. And what is contract? So contract define what crosses their boundaries. So contract define what actually crosses the boundary of bounded context. So contracts can be, you know, entities that business domain have in common. So if bounded context will cross each other, that is, if domain principle, if domain application must interact with each other, they must interact through contracts, which define what they actually have in common. You understand? So the contract is what business domain have in common. And if they must interact at all, if the applications must interact, they must interact through the contract. So the business contracts tie business domains together. Partnership and share kernel require strong team cooperation. So in domain partnership, so through share kernel, so there must be team cooperation. So the team must understand how the domains are connected, and the team must also understand the contracts between each business domain so that they can interact together. For example, when I was working in Seplat, I told you I work with various departments. For example, I'm a data engineer and I sit in IT department. So I work if I want to work with anyone in procurement department, they will have to come to me through the IT manager and through my line manager to get me to work in their department. So that is just like the bounded context, because an engineer cannot sit in a procurement department because I am not a specialist procurement data engineer. I'm just a generalist data engineer, and I sit in IT department, for example. So in terms of data domain, so if procurement data is to connect with finance data, they will connect through a shared, primary key or foreign key, or a shared ID that connects those data together. And that ID is now what is called contracts here. So an anti-corruption layer protects a consumer from a foreign model. So this is just saying that this is just throwing more light on how you should or prevent one domain from corrupting another domain. So you can design an anti-corruption layer. So you can design, even though the bounded contexts are connected through contracts, there must still be, a boundary that the contract cannot cross. There must be a rule that will say, okay, this contract can only go to this length. It can't cross beyond this length to another length. So you should design an anti-corruption layer to protect a consumer from a foreign model. An open host service exposes a stable published language. So if you are using one platform to host one domain application, and you use the same platform to host another domain application, they can expose each other's model to each other, and therefore there can be corruption or loss of information or exposure of things that they are not supposed to see. So you should make sure that you design anti-corruption layer to prevent this. For example, in data engineering, there's what we call the role-based access control. So if I give access to a particular finance data mart to somebody, I cannot give this access to that data mart. I cannot give an access to somebody in HR, so access finance data mart, for instance, because it is not their data, and that data is not within their bounded context, so they must not have access to it. So a context map shows both architecture and team relationship. So you can use an architecture to show context map. You can use an architecture to show how, how one department or how one business domain connect with another business domain, so that this map, this architecture and map will show the relationship between them, and they will not connect, they will not form another relationship outside that predefined relationship to work with each other, or to access each other's application, or to access each other's data. So there must be a context map that will connect those domains together. So how do we implement this in agentic system design? So CADABA need a cognitive context map showing specialist agent and their bounded context. So you must have a context map in agentic system design, and this context map must show specialist agent and their bounded context. Okay, so every agent with their bounded context must be designed. Then command, event, and share contract. This context map must connect command, event, and share contract between them. Must also connect memory and data ownership. Okay, so each agent A cannot access agent B memory because they are not solving the same problem. So each agent have their own memory and they have their data ownership. Okay, so two permission. Each agent must have a bounded context or context map that will map them to the specific tool that they can call. For example, agent A that is solving problem A cannot call the same tool, or cannot call to B that is meant for agent B to call, because the tools, tools have their name and they have their functions. So agents should have access to the tools that is meant for them, not to the tools that is meant for another agent. Upstream and downstream dependencies. So this context map must also map upstream to downstream dependency. So every upstream must be mapped to their specific downstream. And then the context map must also be designed for human approval points. So whenever a task is beyond the capability of an agent, the agent should directly map the task to a human for approval. You understand? So that is how you can implement context map for every agentic system design. So you can see that this book is very, very applicable in data engineering. Not only in software engineering, it is applicable in data engineering, applicable in agentic system design. So a shared kernel should be restricted to stable items such as message envelope, identity type, correlation metadata. So CADABA should use anti-corruption layers when integrating legacy ARP, external AI models, or inconsistent enterprise database. Okay, so these are ways that you can use domain principle and integrate bounded context into agentic system design. So thank you. This is the end of part 1. So when we come back later in the day, we'll be starting with part 2 of the book, which is tactical design. So then we'll begin with chapter 5, which is implementing simple business logic. See you then. Bye.